Okay, so we've talked about and functions, or functions, or sorry, I should say and gates, or gates, not gates. So and is when two events are true, then the output is true. An OR gate is when one or the other event is true, then the function is true. And then the NOT gate is when the input is not true, is the output true? Okay. And there's at least one other one, only one other one that we're going to talk about, which is called the XOR gate, it's kind of like the exclusive OR function, meaning this event or this event, but only that event and not that event. So it's this or this, but only this or this. Okay. So okay, let's show. Here's the little truth table, right? So when input one is zero and input two is zero, great. The function is false, right? That's of course. Uh, and then when input two is one, but input one is zero, then the function or the output is true, right? Is one. And then, of course, when the input one is one or true, and then input two is zero or false, then your function or output is one or true. But here's the key, right? If both are true, so if both inputs are one or true, then the function should output a zero. Okay, it should be false. And the question is, how do we get a single layer to do this? And the spoiler is you can't. Okay, I'm going to show you why. Um, so for example, if input two, let's start with this second row here. If input two is one, right? Well, if we multiply that input of one by the weight, that should be greater than the threshold. We know that. In order for this output, right, in the second row, in order for that to be one, the weight basically has to be greater than the threshold, right? And this is also true for the third row, right? So in order for the third row, in order for the function to be true, when input one is one and input two is zero, when you multiply the weight by one, that should equal that should be greater than the threshold, right? Which is fine. But here's the problem. What about the fourth row? In the fourth row, when both the inputs are true, right? That's essentially what's going to happen is you're going to add those two weights to each other, and they're necessarily going to be greater than the threshold, right? So if yeah, with the weights set the way they are, right? However they are, it is inevitable that the network will output a one when both inputs are one. If each input is weighted so that it exceeds the threshold, then it is certain then adding them together will exceed the threshold also. So in symbols, right, if weight one is greater than t, right, so weight one is greater than the threshold, and weight two is greater than the threshold, it is inevitable that weight one plus weight two is going to be greater than the threshold, which means that this XOR gate is impossible with a single layer network. And this can be represented or displayed. This is actually called linear separability, and we can show that this in another way, right? And so if like let's so it's like if it's zero, if both the inputs are zero, then nothing happens. That's why this circle is open. So this is an AND function, I should say, right? AND gate. So if it's an AND gate, that means that when both are one, when both the inputs are one, the dot or whatever the data point should be, the output should be true, meaning that in this case, the circle is going to be black or dark. But in all other cases, right? So when both inputs are zero, when input two is one and input one is zero, and when input one is one and input two is zero, nothing happens, right? Whereas only when both inputs are one is the function true. But and so notice though, you can uh, draw a straight line with the inputs, and it will separate the tr when the inputs that make it true from the inputs that make it false. However, you can't do that when for an XOR function, right? So for an XOR function, right, of course, 0, 0, the function is false with 0, great. And when they're both true, you can't, you also, the function is also going to be false, right? Should be. And it's, but you can't do this here, right? So uh, these are these 2 points when input one is 0 and input two is one, as well as when input one is one and input two is 0. That's the only time where you would, fire where the output would be true. And you can't draw a single line in the same way that you can here. And so in the next video, we're going to talk about we're going to do the XOR function with a hidden layer, right? So a multi-layer network.